A very good morning, students. Welcome to my next online class. So this is the continuation video on the same chapter force, and here I am with a new topic, that is center of gravity. So center of gravity is a point where all the weight of a body is said to be concentrated, or you can say a body, if you want to balance, then you have to balance it at center of gravity. Like for example, if I consider this is a diary, right? This diary, if I need to balance this diary, then I need to place my finger at its center of gravity. That means where all the weight of a body is concentrated. You see, if I consider this to be as a body, irregular body, the weight of at different point will be acting parallelly in vertically in downward direction, right? So there should be a point G, that is center of gravity, where all the weight is said to be here concentrated. Like you see, the position of center of gravity depends upon how many factors? It depends upon a regular or irregular shape. That means the shape is regular shape or irregular shape. If it is a regular shape, there will be uniform distribution of mass, and if there is irregular shape, there won't be any uniform distribution of mass here, right? So it is very easy to balance a regular shape object, though there are other options, there are ways to balance or to find the center of gravity of irregular shape also. So one by one we will see how to balance a regular shape. Okay, uniform or non-uniform distribution of mass. So this is the second factor upon which this center of gravity depends. There is the position of center of gravity depends. So next one is the distribution of mass. So you see, a regular or irregular shape or uniform or non-uniform distribution of mass. So these are the factors upon which the position of center of gravity depends. Now we'll come across different uniform shaped object, okay, whose center of gravity is fixed. So we can determine the center of gravity by looking its shape only. You see what is determination of center of gravity of a disc. So disc in a spherical shape, so center of gravity lies at its center, right? Next we have a square. So the center of gravity of a square lies at the point of intersection of its diagonal. If I draw one square here, if I intersect both the diagonals, that means if we draw a line from extremes to other extreme, then at the point of intersection, that is the center of gravity. That means at this point the total mass or total weight is concentrated, right? Now you see, center of gravity and center of mass. If it is a uniform shape, that means if the shape is fixed, uniform body, then center of gravity and center of mass, they lies at the geometrical center, right? Next, parallelopiped. Parallelopiped, when I say, that means let us consider here, I will redraw the circuit once more. This diagram. So first I am drawing one cuboid, right? You see, I have drawn one cuboid. Now if I need to join here these diagonals with this, right? So in a cuboid, if I consider it to be as hollow box, so from the inside diagonals, if we draw a line, so the diagonals will be meeting at a particular point, okay? At a particular point they will be meeting and they will be finding as G. So this was the parallelopiped. So it is the center of gravity lies at the point of intersection of all its spatial diagonals. That means internally, so how many corners will be there inside? So from corner to corner, opposite side, if you draw one imaginary line, so the point where all the imaginary lines are intersecting, that is considered to be as center of gravity for parallelopiped, right? So next, regular shape, we have cylinder. So in a cylinder, you see, if we draw an imaginary line cutting the cylinder at its center, that means this axis if we draw, and the center of that axis, that means middle point of the length of that axis is said to be as center of gravity. So that CG stands for a center of gravity. Center of gravity lies at the middle point of the length in the axis, that is middle point of the length. That means if I consider 5 cm is the length of that cylinder, that is the height of that cylinder, then at 2.5 there will be a center of gravity, and make sure that center of gravity is lying along the axis of the cylinder, right? So these are the center of gravity some regular bodies. So last we have triangular lamina. So triangular lamina means here we will be drawing medians from each and every corner, and the point where all the three medians are meeting, that is considered to be a centroid, and this is the center of gravity. That means center of gravity lies at the position of intersection of all its three median called centroid. That means from the three corner we will be drawing three median, and at the point of intersection of three median, so there will be a center of gravity. Okay, so you see, just I would like to summarize what we have learned today. So what is center of gravity? The position of center of gravity is a point where whole of its weight is supposed to be acting. That means an object can be balanced by balancing it at center of gravity. Now center of gravity we can determine, or we can find out by looking its shape, whether it is regular shape or whether it is irregular shape. Now if it is a regular shape, we can easily find its center of gravity like circle or the sphere, square, parallelopiped, cylinder, triangle. We can determine its center of gravity, right? Also it depends upon distribution of mass, whether the distribution of mass is same or not same, right? So these are the two factors on which the position of center of gravity depends, and these are the examples of regular bodies, right? So next we will see how to determine the center of gravity of an irregular object. So next we will find how to balance an irregular shape. Suppose let us consider this is a body which is having an irregular shape, and we need to find its center of gravity, right? So first we will make one hole here, right? And from here we will pass one string, and we will suspend a plumb line. So this is the plumb line. I hope you have seen this one in our practical life, like those who are working in a construction department, like, or they are building home, or you can say mistris and all. They are using this type of device to see the level of a wall, or to find, for many purposes they use this one as a plumb line. Like, so what we have done, we have taken one irregular object whose center of gravity to be determined. Now from here one hole, we have made one hole, and we have passed the string from there, right? And along that string we have suspended one plumb line. So let us consider this one to be as A1 and B1, right? We mark this one as A1 and B1. Now similarly we will turn this body, and we will make another hole here, and similarly we will rotate it, and again we will pass that string here. So it has been seen that if it is being suspended here, then let us consider this is to be A2 and B2. So first we will be suspending at A1 and B1. Now we will open this one. Now we will rotate this one, and again we will make like this hole, and again we will pass that string and the plumb line through that hole. Let us consider that to be as A2 and B2. So similarly we will be doing for other, like A3 and B3. A4 and B4. So it has been seen that at a point where all are intersecting, there we can determine the center of gravity. Okay, so center of gravity we can determine of an irregular body by using a plumb line, by suspending a plumb line. So by making one hole and passing the string over there, and we will place one plumb line, so we will be getting a point, let us consider A1 and B1, they are passing through this line. Similarly we will rotate, and we will put a hole, and we will suspend a plumb line again. So again it will be seen in the second diagram. When we will draw this one, it will be looking like this. A2 B2, right? So A2 B2. So similarly again we will rotate this one, we will get A3 B3. So at a point where all the axes will intersect, then that point is said to be as center of gravity. So let us consider there's to be a rod, half of it is made up of steel and half of it is made up of wood. So we need to balance this rod. Okay, we see that there is non-uniform distribution of mass. So half it is made up of steel and half it is made up of wood. We have to find its center of gravity. So center of gravity can easily be determined by placing a knife wedge at its bottom. So we'll place a knife edge and we will balance this one. Okay, at a point where it will be balanced, like for example it is balancing here, right? So this position is said to be a center of gravity. Okay, so like this experimentally when we were balancing this one, when we were changing its position, this knife position when we are changing to balance the rod horizontally, so it has been found that this is at the end of steel. So when the knife wedge, when you have brought here, so it has been balanced at this portion of steel, not at the portion of wood. So the point at which the knife is balancing this whole horizontal rod is the center of gravity, right? So next topic we have stability. So an object is stable when it is fulfilling these two conditions. So the first condition is the position of center of gravity and the area of its base. If the center of gravity of that body is near to its base, then we say an object is stable. An object is stable if we say the base of that object or base of that body is wider, large. Like for example, you see, if I consider one bottle, right? So it has a one cap. Okay. Now it has been placed on a horizontal table. Okay. If it is half filled, if it is half filled with water here, right, the center of gravity will be shifted here, right? Center of gravity will be shifted here and it is near to the base and base is also wider. So we say that this is in stable position. But if we take in the opposite, if we try to rotate this one, if you try to rotate this one, now you have tilted this one, right? Still the bottle is containing water. Now you have tilted that bottle. So when you have tilted the bottle, center of gravity is here, it has shifted at this point, but the base is very small, you see. So this object is not stable, but this is stable, right? So what are the two conditions body should have if it is to determine its stability? A body should have wider base and the center of gravity should be near to its base. Now one more thing, why it is required, why is wider base should be required? Because when you draw a perpendicular line or a line, okay, imaginary line, it should pass through the center of gravity and it should pass through the wider base. If the center of gravity is here, if we draw a imaginary line, if it is not passing through its base, that means if it is not passing through this portion where it is balancing this object, whole object, then this line is not passing through this base, you see. So this cap, so therefore it is not balanced, okay. It has less stability as compared to this. Now stability also, it depends upon its mass. Now you see, when the bottle was empty, suppose if the bottle is empty, then center of gravity will be its geometrical center. Suppose at the geometrical center, let us consider the geometrical center is at here, then center of gravity should be here. But when we fill this bottle with some water, the center of gravity will be coming towards the lower end of its base. Okay, so from here what we have understood? We have understood that center of gravity depends, or the stability depends upon the center of gravity, and center of gravity depends upon the shape of the object, right, which we have seen just before this topic, right, whether it be regular or whether it be irregular, and the distribution of mass. So due to distribution of mass also, this center of gravity changes its position. As I was talking, if the bottle was empty, center of gravity was here. Now if you fill with this bottle with this water, then center of gravity will also be changed. And always, if the center of gravity is near to its base, then the object is stable. So let's see one more example. For example, we have learned that if we pour a small droplets of mercury, it is in spherical shape. But when we put a big globule of mercury, means big drop of mercury, then when it rests on the flat surface, means horizontal surface, it looks like this, that is flattened at one end. Okay, so why it gets flattened when the drop is larger or bigger, and why it is spherical when it is small? When it is small, okay, cohesive force acts on it and the object regains its spherical position. But when the droplets of that mercury becomes heavier, what happens? It becomes flattened, because center of gravity, in order to make it stable, center of gravity comes very near to the base. Okay, so that was the stability. That means mercury, when it is having heavy drop, that is bigger drop, it also tries to attain its stability. So how it regains its stability? By lowering center of mass to its, or center of gravity to its horizontal surface. So that is why this spherical shape becomes it flattened at one end. Okay, so this was the factors on which stability depends. So students, for this class only this much. So prepare up to how much I have taught, right? So start making notes. So these topics which I explained on the board, that topics you can write from your book itself. Okay, and prepare very well. So see you soon in my next class.